Hello dear audiences, this is the first lecture for the probability and statistic, and as you can see in a picture that we have it over here, we will discuss about plotting this type of the nice graphs, and most probably you work with that type of the chart in the PowerPoint or Words or Excel or any type of this programs. So I am Mohammad Momenzadeh and we will start to discuss about these things in this lecture. If we take a look at the topics that we will discuss about it in this lecture, you can find the basic definition, frequency table, measure of location, mean, mode, median, quartiles, and measures of variation. We will discuss about these things, and at the end of the day we hope that we can indeed somehow sketch the diagram for this type of the measurement. So we start our discussion by the basic definition. As you can see over here, we have the definition for the statistic. A statistic is concerned with scientific methods for collecting, organizing, summarizing, presenting, and analyzing the data. These are the steps that we follow in collecting the data in any type of the cases that we study a population. And what is the meaning of the population over here? The population is a source of things that we study on it. So over here in collecting, therefore it is often impossible or impractical to observe the entire of the space, entire of the resources. For example, sands on a beach are too much to study all of them. But if we want to know the size of the sands on a beach, we should collect the data and follow these statistical things that we talk about it over here. We should collect the sands on a beach, then organize them, and then summarize the data and presenting and analyzing the data. And all of these processes over here is resulted to reasonable decision of such an analysis. So over here we have some example of these things. If we just take a look at the shape, let me show you what's gonna be happen in this case. So you can see over here we have the space of population. If we consider the population over here, let me just use this things to show you what's going to be happen. We have a population over here, and if I just put it over here, the name of the population that we talk about it can be considered as this circle, and we draw a sample from this population. Means that we select some elements over here. For instance, if we have some elements over here in a population X, Y, Z, then we can take a sample, draw a sample from this population. This sample is drawn from the given population. Then by collecting the data from the population, we can study the population. As I said it over there, we cannot study the population directly because it's impractical sometimes and it's impossible sometimes to study all elements in the population, the entire space. Instead of that one, we draw a sample from that population and we study the sample instead of the population. So let us return back to the slides to see what's happened over there. As you can see over here, the data also has a meaning, a collection of values to be used for a statistical analysis. And a raw data is collected data which does not need to be numerical. Weights of certain set of a student is an example of that one. Days of a weeks or something like that. Means that we have a raw data and we have the definition of an array, which is the arrangement of raw numerical data in ascending or descending order. So if we collect the data, we need to make a table to summarize them, and somehow we just make the organization for that type of the data. So For that reason, we need to understand some type of the concept. The first one is a range of a data which is equal to the maximum data minus the minimum data. Then we have a class of intervals, class of interval size, class frequency, and class marks. And at the end of the day, by using this type of the thing, we sketch the frequency table. So let us take a look at the example and practically let us calculate this type of the things. If we just take a look over here, we have an example. We have a data over here. These are the raw data that is started from 20, 30, 35, 33, 23, 24, and so on. So as you can see over here, these data are not ordered, means that it's not ordered by the minimum to the maximum. So we have 20 over here, 30 is bigger than 20, 35 is bigger, but as you can see over here, 33 is smaller than 35. So means that these data are not in one order. So when you have some data over here, the first thing that you should do to construct the frequency table, this is the result at the end of the day after that we collect them and summarize them in one table. We call this table as a frequency table. So to construct this table, the first thing is counting the number that we have it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 data. So we have 14 data, so the number of n, or the number of data over here, is equal to 14. As you can see over there, the number of n, or the number of data, is 14. The next thing that you should calculate it is a range of a data, and as you saw in a previous slide, the range of a data is equal to the maximum data, or we denote it by the x max minus the x min. Means that we just subtract the maximum, the minimum from the maximum, and the result shows the range of a data. So if you take a look on a data, the smallest data that we have it over here is 20, and the biggest one, the greatest one over here, is 60. So the subtraction between 60 and 20 means that the maximum over here is 60, the data that we have it is 60, and we subtract 20 from that one, means that 60 minus 20, then the result give us the range of a data, which is 40. Means that the data range between 20 and 60 if I just consider the data in one line. If I just assume that we can put all the data in one line, then I can range the data between the number 20 and 60. Means that I can assume that this point is 20, and this is the smallest data that we have it over here, and the biggest or the greatest one over here is 60. So all the data that I have it over here range between these values. Means that you can find all the data in this interval. Means that over here, it doesn't matter that how it's split over here, but the data separated over here between 20 and 60. So because of that, the range of the data shows over here that the data that we have it range between 20 and 60, and R, or the range of a data over here, is equal to 40. So this is the first measurement that we have it for calculating the table of the frequency. After that, we find the range of a data over here. We should decide about the number of the classes, and we use the simple formula for that number of the classes. We denote it by k over here, and the k is equal to roots of n, and roots of n over here means that roots of number of a data which we calculated before, it was 14. So roots of 14 should be calculated, and roots of 14, it's equal to 3 point something. We all the times we round up this value to the higher number, means that we round it up. So roots of 16 is equal to 4, so roots of 9 is equal to 3. So this value that we have it over here means that roots of 14 is equal to this value is equal to 3 point something, 3 point something over there. So we have something over here. So we round it up. It doesn't matter that it's 3.0001 or 3.999. So we round it up to 4. Means that the number of the classes that we should consider to construct the frequency table should be 4. And as you can see over here, we have 4 classes. This is one class, second one, third one, and the fourth one. So we should divide or split the data in 4 classes. Means that between 20 and 60 that we consider it over here as a minimum and maximum of a data, we should divide this range to 4 classes. So we have 1, 2, 3, and 4 classes over here. And for this reason we have the length of each class that we denoted by L, the length of a class, which is equal to the range over the number of a data that we have it. So the number of the classes that we have it. So the range or 40, which denotes the differences between the maximum and minimum of a data divided by the number of the classes. So it shows that each class should have a length of a 10. Means that each of this division or splitting that I mentioned it over here should be considered as a 10. So we divide them and each of them has a 10 lengths. So if we start by the smallest one, which is 20, then we should go forward and the next number should be 30. And so on. Means that the next one should be started from 30 to 40, 40 to 50, and 50 to 60. These are our classes. So as I mentioned it, by calculating the range of a data, we found the differences between the data, which is 40, and then we choose the number of the classes by calculating roots of n, which is equal to 4. And at the end we calculate the L or length of each class, which is equal to 10 over here. And for this reason our classes is started from 20 to 30, 30 to 40, 40 to 50, 50 to 60. So the question over here is about this borderline, the class limits over here. As you can see, we have a number 30 over here and 30 as well in the next class. The question is that the number 30, for example, we have 30 over here as well. It's 30 in our data. This 30 belongs to the first class or the second class. So you should consider the class limit to understand this range. Indeed, we shift the border of the classes such that the 30 belongs to the second class in this case. So as you can see, the limit classes over here, the class limits over here should be calculated such that the numbers, the data over here clearly can be categorized in a right class. So if you have a 30 as a number, this 30 belongs to the second class. This is true for the 40 as well. Means that if we have 40 over here, which we have 40 as well here, then this 40 belongs to the third class. Means that it belongs to this class, not to the previous one. So always we just subtract half of the complete digits between them. Means that we just look at the data. We have 22 and 23. The smallest differences between the data is 1 unit. As you can see, we have 22 and 23. And the smallest differences between the data is 1 unit. So this 1 unit is divided by 2. And then if we divide this 1 unit by 2, then we have half. And with that half, we can construct our class limits. What does it mean? Means that we subtract this half from each of the classes border. Means that from 20 I subtract half and it becomes 19.5, and I construct this I subtract this half from 30 as well, and it's gonna be 29.5. Then I have the class limits. So with that class limit, we can distinguish between the data and consider the numbers in a true classes. So for this reason, for the class of 20 and 30, let us calculate the numbers that contains in this class. The first one, 20, belongs to this class, 20. So 30 is not belonging to this class because, as I said it before, 30 belongs to the second one. 35 as well. The another number is 23, which is between 20 and 30. The another one is 24, and the next one is 22. And let us see if we have one more. Yes, we have one more. So 1, 2, 3, 4, 5. And as you can see over here, the frequency of this class is equal to 5. For the next class as well, we do the same thing to calculate the frequency. We denote the frequency by F, and because it belongs to the class I, then we denote it by F of I. Means that this is 5, and this denotes that the first class has a frequency of 5. So for the second one, we have 30 and 40, the class of 30 and 40. 30 by itself belongs to this class. 35 as well. So we have 2, 3, the third one, 23 and 33, and we have 30 as well. So 40 is not belonging to this class, and the another one is 30, and the last one is 35. And as you can see, this purple circles, we have 1, 2, 3, 4, 5, and 6. So, and the frequency of that one is equal to 6. The only number that belongs to the class of 40 and 50 is 40 by itself. And as you can see, the 40 is only number that belongs to this class, and the frequency is equal to 1. And the remaining numbers means that the numbers that remains over here means that 50 and 60, these two numbers are belonging to the last class, and we have the frequency 2 over there. So the another thing that we have it here is a class mark. The class mark is calculated by the xi, the x of maximum of that class. Let us put the x of that class, x of max minus plus xi. Let me just put it by xi and xj. So the xi plus xj, which denotes the minimum and maximum of that value, over 2. It looks like an average of that numbers, means that between 20 and 30, the midpoints over here, or the average over here, is equal to 25. It only needs to add 20 by 30 and divide it by 2. So if you just add 20 by 30, 20 plus 30, then 20 plus 30 is equal to 50, and if you divide it by 2, then the result will be equal to 25. So the class mark is 25. The class mark over here presents the property of that class. What does it mean? Means that when we divide and split these classes and we find this part, then we just take a look at the midpoints. This midpoints over here is 25. So this 25 determine the property of that class and represent the property of that class as well. Let me just erase this part to show you that what does it mean in this case. If I just take a look at that line again and I split the data between 20 and 40 over here, let me just put it here, the value that I needed. So if I just consider this one over here, let me just use the pen. It's a bit difficult to use this program. So yes, here we go. If we consider the number 20 and the another number, the maximum data that we have it, which is 60 over here, we split them, and we calculate the range of the data over there. So if we just denote the range of the data over here, as I said it before, the range of the data over here is equal to the differences between 60 and 20, which is 40. And when we just calculate the number of the classes, then we split them to some parts. So over here we had 4 classes, so we split the data to 4 parts. And after that one, we calculate the length of each class. The length of each class over here means that the L is equal to the range over K, the number of the classes that we calculated, and it was 10. After that, we divided. The class mark over here is a midpoint, means that this point, which is equal to 25. This point that we split it is 30, so the next midpoints will be 35. So this is the next class mark over here, which is 35. The next class mark over here is 45. And the next class mark that we have it, or the last one over here, is 55, which is located in this point. So these points, the class marks that we have it over here, present the data. Means it doesn't matter that we have a data at the left side of that one, too many data over here, or if we have a data at the right side of that data in this class. We present all the data on that class with that class mark. Means that 25 represent the property of that data. So let us take a look at the next slide. So if we just take a look at the next slide over here, we can see the frequency tables, as I said it, and I just explained that how can you construct the frequency table. The steps are written over here. You can take a look on it, and in the next step we should discuss about the measure of location. So let us talk about that measure of the location here. So up to this point, we construct our first frequency table successfully. Right now, we want to talk about the measures of location. So we have two types of the measures. We have measure of variability and measure of location. So each of them give us some information. At the end of the day, we will discuss about the differences between these two types of the measurement, and we will talk about them. So right now we want to talk about the differences between them. Measure of a location, we have mean, mode, median, and quartiles, and so on. Means we have several type of the measurements over here. For measure of variability also, we have range, standard deviation, and variances. For each of these measurements, we will discuss about the calculation of them for a table of a frequency and without the table of the frequency. Means that when we have a raw data or we have a table of the frequency. Let us start by the first one, which is the mean over here. So let us take a look at this slide. So before that we're going forward, it's necessary to know these symbols, the summation or the sum of the numbers. So as you can see, this is the Greek alphabet, the sigma. We have the lowercase and uppercase of a sigma in a Greek alphabet. This is a lowercase of sigma and this is the uppercase of sigma. And this is the first letter of a sum or summation or addition of the operation of adding the numbers. So as you can see, when we have a sigma symbols, it's only a symbols over here. When we have a sigma symbols over here, we have a lower part and upper part. At the lower part, we wrote over here n equal to 1, and it's going forward up to 4 for a number n. Means that you should repeat the number n over there from n equal to 1 up to 4 and add all of them together. Means that this sigma over here, these symbols of sigma over here that we have it there, these sigma symbols over here, determine the addition operators that you can see between these numbers, and the series of 1 up to 4 should be written instead of the n. And if instead of the n we have n plus 2, for example, then we repeat this n plus 2 at each stage. As you can see, we repeat it over here, and over there. And instead of the n, for each stage we put 1, 2 and 3. Means that instead of this n at the summation part, we wrote 1, 2 and 3. And if there is no n in a summation, for example, over here we have 4 inside of the summation, then that number 4 is repeated 3 times without any changing. So this is a summation symbol, and I hope that you understand the symbol of the summation over here. In the next slide we will discuss about the mean of a number, the sample mean. As I said it, when we discuss about any type of the measurement, we will discuss about it in 2 cases. One case is if the raw data are given. For example, if we have some data over there, for example, if you have 2 and 3 and 2 and 3 and 4, for example, if you have 3 separated data over here, and if we want to calculate the x bar or the mean of this data, the symbol that we use it is a x bar, then we should add them. You learn it from the high school, it's very easy. You should add them, 2 plus 3 plus 4, and divide by a number of the data that we have. We have 3 data, so we should divide it by 3. Over here, if we want to use a symbol, then it means that we add, or we use a summation notation. We add xi. Xi denotes the data, means that the first data that we have it over here, this data that we have it over here is x1. The second data is denoted by x2, and the third data is x3. So we have 3 data, x1, x2 and x3, and instead of 1, 2, 3, I just put xi over here. The xi indexed by I, when I started from 1 up to 3, we should add them and divide this value by a number of the data, or n, that is equal to 3 over here. So n is 3, and we add them 3 times. We add them 3 times, 2 plus 3 plus 4, and we divide it by 3. This is a method of calculating the average or the mean for a sample. What about the population? How can we calculate the population means? So if you understand this part carefully, then you can follow this discussion for the remains parts when we have the table any other places. So let me just put this example over here to just discuss about this example. So we have a frequency table, as you can see, and for this frequency table we have several values. So this table is given, and they ask you to calculate the mean of a data based on this table. So when we have a data over here, let me just sketch the data on one axis here. So if you have an axis here, so in this axis that we have it here, let me just put one arrow to show the side of a data. Then as you can see, the data is started from 10, and we have the classes from 10 to 20, 20 to 30, and 30 to 40. So means that our data are separated between 10 to 40. So based on this table, I sketched the given data over there. So the another data that we can construct it here is their frequency. So as you can see, the frequency of the first one is 2, means that we have 2 data between 10 and 20, but we don't know what is that data exactly. That data could be 12 and 14, it could be it could be calculated, or it could be assumed as a 40 and 60, 18 and 19, or any numbers. We just know that we have two data between 10 and 20. But how can we consider two data over there? Instead of these two data, we just use the representing data, which is a class mark. If you remember, we just consider the class marks of 10 and 20 as a 15. So instead of guessing about these two numbers that we don't know what is their location, I assume that we have 15 two times over there. So means that when we said that the frequency of the first class is equal to 2, and these two numbers are between 10 and 20, instead of knowing the place of them, which it could be 10 and 10, both of them could be repeated at the point 10, both of them could be 19, but we just consider these two numbers as 15. We just use the represented values over there. This is as the same for the second class. In the second class, we have a frequency of 3. And this class is between 20 and 30. Means that we know that we have 3 data between 20 and 30. For example, assume that these 3 numbers are here. So instead of knowing that, we just use the class mark again, which is equal to 25, and we assume that we have 3 times 25, means that instead of 3 data that we don't know what is their places, we consider these 3 data as 25, means that we have 25 3 times over here. And for the last class we do the same, means that at the last class we know the value, the frequency is equal to 5. So if the frequency is equal to 5, means that we have 5 data between 30 and 40. Let me just mark them here, 3, 4 and 5 data. And instead of considering 5 data that we don't know what is their places, I just use the class mark again. Between 30 and 40, the class mark is 35, the midpoints over there, and I assume that 35 is repeated here 5 times. So means that if we just consider it here 35, then I can assume that this 35 is repeated over there 5 times, and in this way I can get rid of this calculation. So it's better to repeat it to over here instead of writing there and copy and paste it. So 35, as you can see, 2 times, 3 times, 4 times and 5 times, means that the given table is as the same as these numbers, because we cannot guess the place of the numbers exactly. So right now, again, for calculating the mean that we denoted over here by the mu, the another Greek alphabet mu, we can add these numbers and divide by the number of the data that we have it here. Means that we should add them, we should write them here. So let me just write them here. If I just use this one, I can add them. So 15 plus 15 plus 25 plus 25 plus 25 and plus 35 plus 35, 5 times I add them together. So and at the end of the day, for calculating the mean, as you remember, we divide all of this summation by the number of the data. 1, 2, 3, 4, 5 for 35, 3 over here 8, and 2 it becomes 10, and we divide them by 10. By the other words, if we want to summarize this calculation and write it over here, we use a summation of fi, frequency of them, multiplied by xi, or the class mark. Means that we multiply the frequency by the class mark. As you can see, I is started from 1 up to k, the number of the classes that we have it here. So we have the first one. As you can see, for the first one, the frequency, the F1, the first frequency was equal to 2, means that we should multiply them by 2, and x1, or the first class mark, is here, is equal to 15. We multiply 15 2 times by itself. And right for the second part, the F2, or the second frequency that we have it over here, is equal to 3. So we multiply 3 by 25, which is a class mark for the second group of a data, for the second class that we have it, 25. And for the last one, we have the frequency of 1 2 3 4 5. So the F3, the third frequency, is equal to 5, and we multiply this 5 by x3, which denotes the class mark for the last class. So the last class over here is 35, and at the end of the day we divide them by the total frequency, which is 10, and this 10 is a summation of fi, the sum of the frequencies over here, where I is started from 1 up to k, I mean the number of the classes that we have it there. So means that this 10 is the addition of f1. F1 is 2 plus f2, the second frequency, and the third frequency, which is 5. And if you add them together, 2 plus 3 plus 5 is equal to 10. If you understand this one, then for calculating the mode, mean, and quartile, you will not have any problem, because as you can see, this frequency table can be interpreted as a numbers of a class marks with the given frequencies. Means that when we have these classes, as you can see, between 10 and 20, we have frequency of 2. Then it means that 15 repeated 2 times, and we have 215. And instead of class 20 and 30, we have a class mark of 25, and it's repeated 3 times. So we repeat it over here 3 times. And for the last class as well, we repeat it 5 times. Now it's a time to discuss about the next measurement, which is the mode. So let us take a look at the mode. The another measurement that we have it here. So regularly in real words, we call something as a mode when we have most frequency over there, which it has a more frequency, and most of people follow that type of the things. The mode in the data are as the same. Over here we have some example that some data, the raw data, are given 1 2 3 3 4 5, and as you can see, 3 is mostly repeated and 2 times is repeated indeed, and the mode of this data is 3. For the next group of data, we have 2 2 3 3 4 and 5, which 2 is repeated 2 times, 3 repeated 2 times, and 4 and 5, which has a single value over here. The mode over here is 2 and 3. We will not take an average or the mean of them. We just say that the mode of this data is 2 and 3. We will never add them or take a mean of 2 modes if the data has 2 modes. But if the data has more than 2 modes, then we said that the data has no mode. Means that we just allow to have a 2 modes, not more than that one. For this reason, in the third example over here, we have 2 2 3 3 4 4 and 5, which 2 3 and 4 repeated 2 times, and 5 is single over here, and because of that we say that there is no mode. This is the rule for the mode value as a measurement. And again, if we have a frequency table, we just look at the class which has a more frequency, and as you can see, the frequencies over here are 2 3 and 5. It seems that the 15 is repeated 2 times, 25 repeated 3 times, and 35 repeated 5 times, and for this reason the mode of this table will be 35. 35, approximately is 35. Indeed, the data that we have it over here is not obviously clear that which data is repeated, and because of that we say that the class mark of a data where we have a most frequency is considered as a mode, and it's gonna be 35 over here. So this is the mode as well. We just finish our lecture over here in this point after we discuss about the mode, and for the remained parts means that for the quartiles, for the mean, and plotting the graph, and also the measure of the variation, we will discuss about it in a next lecture. Thank you for your attention.